Why don't we get started? Hello everyone, welcome to today's webinar on wireless pneumatic thermostats and GPG's Outbrief series. My name is Mike Lowell and I'm a project manager with GSA's Green Proving Ground program. I will be facilitating today's presentation. Andrea, next slide. Today's webinar will include a brief overview of GPG by the director of the program, Kevin Powell. After Kevin's opening remarks, we will transition to the technical portion of the webinar. Dan Howlett from Oak Ridge National Laboratory and the primary investigator for the GPG assessment of wireless pneumatic thermostats will summarize the research results. Next slide. The broadcast today will be listen only. You may submit questions by using the chat box on the right side of your screen. You do not need to wait until the Q&A session to submit your questions. In fact, we are encouraging you to submit your questions well in advance of the Q&A session. And now for an overview of GPG, here's Kevin Powell.
Well, thank you, and I want to thank everybody who is joining us here on this, this webinar. So next slide. Just a couple of words about what the GPG program is, why GSA has stood it up, and why we continue to fund it, even of course in this time of some fiscal constraint. In short, what we as an agency recognize is that the most efficient way and really the only way to do more with less, which is of course the current operating parameter that we're all under. And I think that's not just the federal government, that's actually everybody in the world of corporate real estate, is really through innovation. People really, there's a tremendous amount of innovation going on. A lot of it is driven, in fact, by the market wanting to make a better building than the last one. The GPG program is a one-stop shop for GSA to identify those technologies, the most promising technologies out there that have the ability to really, excuse me, move the needle on our building's performance. So for over the past 6 years, we've received, in fact, about 100 applications a year. So about 600 applications have been received. About 10% of those are selected for M&V. M&V happening out there in the real world of our buildings. So far, we've published about half of those reports, and that is to say, they've concluded the field work, and we've publicly published the results. And about 20 of those we've recommended for broad deployment. That is to say, they have a broad applicability, we believe, for our federal portfolio. Some of the ones that we might not recommend for federal deployment, in fact, might have applicability in other portfolios. And of course, this technology we're going to talk about today is exactly the sort of thing that we're actually very excited about. Again, been selected for the program, rigorous M&V. We know we have a pretty good sense of how it can work in the real world. And then, of course, what we want to share with you is how that can, why you should, in fact, deploy it and where you should deploy it. Next slide. So just a couple of notes about how our program works. The key thing when we stood up the program, what distinguishes, I think, our program from quite a number of other efforts that are out there, particularly in the private sector, is that ours, because it is funded by you, the taxpayer, it's public, it's open, it's transparent in terms of how it works. We hope that you'll find the results to be credible, professional, balanced, and that at the end of the day, we have something that you'll find useful. This is not about reports that are sitting on a shelf or that document the best possible performance a technology could have in a cherry-picked location. But really, this is about something that we believe you could look at and say, yeah, this could make sense for me, for my building. We look at GPG within the context of the division that I head up, the Emerging Technologies Division, as sort of the first phase. The second phase is what we call pilot to portfolio, that being this notion that once we have some results, we want to actually see that they get more broadly deployed. GPG stands for GSA's Proving Ground. Next slide. I want to also alert everybody that we've got a couple of upcoming outbriefs. These outbriefs are in fact something new. This is the second that we're holding, and there's a couple more coming up. In fact, we hope to hold these about once a month. We have enough results to do that. The next one, June 1st, will be a control optimization system for chiller plants. This is how you can run the entire chiller plant as a system and really achieve, again, some pretty impressive savings. In July, I think everybody will want to attend this one. It seems to have a great deal of interest. We're going to look at a couple of technologies that are next generation chiller technologies, a variable speed screw chiller and a magnetic bearing chiller. Both of those have remarkably different and significantly improved performance relative to the current incumbent state-of-the-art. Next slide. That is the transition to Dan Howitt, today's key presenter, our technical lead for this evaluation. Dan?
Still can't hear you, Dan.
Can you hear me now?
Yes.
Hello. Oh, that was odd. Okay. Well, good morning, everybody. As Kevin said, my name is Dan Howitt. I'm a mechanical engineer here at Oak Ridge National Laboratory, and I led the investigation or evaluation of the wireless pneumatic thermostats in 2014. Slide 10, please, Andrea. I want to begin with, what is a pneumatic thermostat, a conventional pneumatic thermostat? A conventional pneumatic thermostat is a device on the wall. It senses room temperature. It's a mechanical device, and it has a small valve that, based on the temperature, it opens or closes and regulates pressure within a pneumatic system. This pressure gets passed through pneumatic tubing. It actuates various devices to control temperatures or turn on fans, actuate dampers. The key part is that to adjust a conventional pneumatic thermostat, you need a screwdriver to change the valve settings, or sometimes they have a small lever on the side that an occupant can adjust. These conventional thermostats, they do have certain advantages. It was the first way to centrally control a large HVAC system. But it also has disadvantages. There's no way to centrally control the thermostat setting. Every adjustment has to be made manually, physically standing at the thermostat. And as far as the control scheme goes, basically they were good to maintain temperature in between two certain set points. Slide 11, please, Andrea. So as energy costs kept rising and DDC control systems became more widespread, there was a desire to retrofit pneumatic control systems with the capabilities that DDC offered. Technology started coming into the marketplace, but these original retrofits all shared a few things in common. The biggest one of which is they had to be wired together with hard wires. This was very labor intensive to route the wiring, especially when the wiring had to go behind sheetrock. It was typically only practical during major space retrofits. But then along comes the wireless pneumatic thermostat technology. With this technology, the only device that needs to be replaced is the thermostat on the wall. The wireless device, it connects directly to the existing pneumatic tubing behind the wall. The wireless device then communicates with other thermostats and with the building management system. What this technology does is it gives the ability to upgrade a pneumatic system so that it has the capabilities of doing DDC controls, but you don't need to run wires behind the sheetrock everywhere. Also, these thermostat devices, the wireless devices, they can feed back information about a building's pneumatic system's health, such as leaks or pressure issues. Slide 12, Andrea. As GSA was looking at this technology, they surveyed their building owners and building managers and found that about 20% of the GSA buildings still have pneumatic control systems that could benefit from the application of wireless pneumatic thermostats. Now, one thing I want to emphasize is that for a building to be a successful candidate for this technology, it has to have an existing, properly working pneumatic system. No water in this system, no leaks in this system. What the wireless pneumatic thermostat does is it gives a building the capabilities of doing a lot of control sequences, but it cannot make up for deficiencies if the existing pneumatic infrastructure is malfunctioning. Next slide, please, Andrea. The test site that we chose for this is the Woodrow Wilson Center. It is part of the Ronald Reagan Conference Center in Washington, D.C. It's quite an impressive building. Slide 14, please. So there are some things to think about if your building looks like a good candidate. First off, as I said before you start to go down this path, you've got to make sure that your pneumatic system is operating properly. Air's dry, no leaks, that your actuators are not corroded, they're all functioning properly. Step one then is to start to look at what are the pneumatic thermostats, what types do you have within your building? Are they heating only? Are they cooling only? Are they heating and cooling to a dead band? How many tubes come into the back of your pneumatic thermostats? What types of actuations do they have? Once you've got all of those numbers and what types of thermostats you have, wireless pneumatic thermostats come in a variety of configurations to match up what you have. Okay, the next thing you need to look at, and the vendor will work with you on this, is the wireless signal. How well can a wireless signal be transmitted between areas of your buildings? Because the signal can be greatly influenced by the building material. Concrete is very bad. However, if you do have a building that happens to have a lot of concrete that interferes with wireless signals, this is overcome by adding repeaters throughout the building. Excuse me. The diagram that you see to the right is one floor of the Woodrow Wilson Center, and the red dots are where repeaters had to be located so that all the thermostats could communicate with each other and with the building management system on that floor. And then finally, you have to figure out where is the central controller going to be located. The central controller can do a certain amount of control schemes with the thermostats by themselves, or it can also interact with the building management system to enhance the overall control capabilities. Slide 7, please. When installing the thermostats, as I've said, this is each wireless pneumatic thermostat is a standalone device that goes directly on the wall, connecting to the pneumatic tubing. The vendor made the claim of approximately 30 minutes per thermostat, and I'll be the first to admit that I'm somewhat cynical and skeptical of vendor claims, but this one actually panned out to be true. It was actually a very straightforward process of removing the old device and putting in a wireless pneumatic thermostat. Again, no wires to run. Next slide, please. So the M&V plan and the results. As I've said several times, the wireless pneumatic thermostats offer a variety of control strategies. To test its capabilities within the Woodrow Wilson Center, we went for a straightforward occupied-unoccupied schedule with a setback. And it happened to be during the heating season that we were doing this. As you can see from the bottom, it was early December. What you're looking at are temperatures taken during 4 days, a Saturday, Sunday, Monday, Tuesday cycle. We used hobo data loggers within the space to measure temperatures, and the evidence is right there in front of you. Friday at the end of the day, temperatures started dropping based on cooler outside air temperatures. Monday morning, when the schedule went to occupied, temperatures rose again to keep everyone comfortable. Temperatures were maintained during the day. End of the day, temperatures started dropping again. You see the Tuesday cycle. I'll be the first to admit that, well, I've said it before, I'm somewhat cynical and skeptical about claims, but this device worked, and it worked across the board. The graph that you see was just from one space, but we actually tested it throughout about 100,000 square feet of the Woodrow Wilson Center. And across the board, it worked and could perform and do what it was claimed to, what it had claimed. And also it was useful for identifying some air leaks during this process. Next slide, please. When looking at the cost effectiveness of this device, the factors that influence the cost, the installation costs of wireless thermostats, same factors that influence a lot of different control systems. The more thermostats, the more individual spaces that you have, that's going to lead to more cost. If you have more private offices, that's going to lead to more cost. We also mentioned that concrete as a building material requires more repeaters. That will also influence the cost. And also one of the things that the vendor mentioned, even though it was not the case at Woodrow Wilson, that it would take longer to install a thermostat on a concrete wall versus a sheetrock wall, just from having to use different types of drills and different types of anchors. Next slide, please. This is a table of simple payback periods. What we did was some basic modeling using an occupied and unoccupied schedule. I need to emphasize that your individual sites will vary. Your results will. Also, it's going to depend largely upon what kind of control sequences that you choose to implement. How robust is your building management system capabilities? What we recommend is to, first off, verify what control strategies are capable there, model the savings that potentially could come from your system, verify the first cost based again on numbers of thermostats, numbers of repeaters, and do the math of a basic economic analysis. Next slide, please. A couple of things to note under best practices. You definitely need to work with a vendor to measure how wireless signals can go in between your occupied spaces. Also, one item that we ran into when we were in the Ronald Reagan Center, the original area we wanted to work in was not the Woodrow Wilson Center. It was a different section of the conference center. But one of the occupants of that area was the Immigrations and Customs Enforcement Agency. ICE, as it's known, had a secure area that they did not permit any wireless signals to go in or out of. Especially within the federal building portfolio, this could be an issue, and it's something that needs to be noted if you're considering this technology. Training, 1 day of training was provided by the vendors, and the operations staff they did give us feedback that they felt comfortable with that training, and they were ready to go forward and work with the system. Next slide, please. Deployment opportunities are really pretty self-explanatory. As long as you've got a pneumatic system that is working properly, it's dry, no leaks, actuators are working, there is really no part of the country where this system does not show potential. The potential becomes limited, only based upon, what are your energy costs. Obviously, higher energy costs make a device like this more economically viable. And how robust is your existing building management system? Next slide, please. This is the conclusion of my report, and Andrea, I'll pass it back to you for information about some specific installations. Andrea?
Welcome. It's Mike. I'll take over now. I have to catch up on the slides. So what this is Mike Lowell, the project manager. What we'll talk about now are some of the actual post-study deployments that occurred within GSA. We had 2 deployments in Region 2 of GSA, which includes New York State and New York City and the upper Northeast. The first one was in Region 2, the Javits building. And as you can see here, a large installation. Actually, both of these were very large installations at 2.8 million gross square feet and 31 of 38 floors. I'll let you read the particulars, but you can see roughly 2% savings. Initial Javits comments after the installation were actually not good after the installation. This is due to GSA's operations and maintenance contractors seeing that the report of the problems, post-installation started getting tenant complaints as well. However, their attitude quickly changed when they responded to the complaints. What they found were that VAV boxes were stuck in place, bad actuators, or no air to the thermostats were causes of the problems. After responding to a dozen of these complaints, they learned that actually none of the complaints were due to the wireless pneumatic thermostats, but instead were due to mechanical issues within the building. So they actually saw that the wireless pneumatic thermostats were acting as kind of a window into operational problems. Next slide. Whoops, looks like the second installation was the Weiss building. Here you can see the return of a smaller installation, 1 million gross square feet. You can see the return was a little bit better, 6.8% savings. Like the Javits building, the Weiss comments initially were not good after installation. This again is due to the GSA O&M seeing reports of problems and getting tenant complaints. However, after seeing the problems and finding out the cause of the problems, they again found that the wireless pneumatic thermostat problems were not a result of the wireless pneumatic thermostats, but mechanical issues in the building. So again, the report there was favorable. Next slide, and I think then I'll turn it over to Ron Allard.
This is Ron Allard. Can everybody hear me?
Gotcha, Ron.
Okay, good. My name is Ron Allard. I am the NCR Regional Energy Branch Chief. I'm also the Technical Committee Representative for NCR from the Green Proving Ground Program, which is this project was done under. We volunteered for this technology. Just go to the next slide, Andrea. We volunteered for this technology in the Ronald Reagan building because we thought it would be a good fit, even though it's a relatively new building. We did pneumatics in there. It's a large building, about 3.5 million square feet, but we had a wing of the building, some wings of the building that had a good fit, so we decided to deploy it there. We had a defined area with one floor we could run this test in. The other thing about the Reagan building made it a good fit is it's got relatively normal, for the most part, government IT concerns for wireless. Some of our customers, State Department, White House, they are a little less receptive to these kind of wireless signals going around their building. So this was, I'd say, relatively normal government level of concern. The thermostats, the reason for it is, the thermostats become a readable points, controllable points on the BAS, and so that was a big advantage for us, allowed us to do setbacks, et cetera, at night. This technology also, because of as Dan already said, trying to retrofit in a building with the expense and the tenant impacts, this clearly becomes a much better option. We got relatively good instructions from the manufacturer, which was helpful. It was a 30-minute install, as Dan had said. Also, we got relatively clear direction and instructions from the manufacturer, and that was a big help when we went out to bid. I think if you talk about wireless pneumatic thermostats, there's not a lot of experience out there. Uncertainty in a scope and it becomes uncertainty in the bid, and that drives cost up. So having relatively clear instructions and relatively simple process, I think kept the cost down to a reasonable level. Talked about, this is a good situation where you don't have to really impact the tenant space very much. And it allows us to do nighttime setbacks, weekend setbacks, and things like that to save energy. Also, because the thermostats are remotely controllable from the BAS, they can be read from the BAS and they can be controlled from the BAS. So if you do have a tenant complaint, you can actually go on the BAS and look what the temperature actually is. Some extent, and you can actually adjust it to some extent. So all those are positives, and I think the experience and the support at the building level for this technology is very good. So we really concur with Dan. We think it was a good installation, and it was a good project for us, and we're happy with the results. And that's pretty much all I have. So I'll turn it over.
Great, thanks, Ron. Before we move on to the Q&A, we just want to make sure that to let everyone know that in addition to everything can be found, more detail can be found online on the GSA website. We have the full report as well as a 4-page findings and a 1-page summary document as well as additional resources. And with that, we'll move on to the Q&A. And Mike, if you want to take that over. Thanks.
Okay. Thanks, Andrea. And so what I'm going to do is just read these questions verbatim. The first question, which I think was answered in a chat, but I'll go ahead and ask it so it can be answered again. Was this system interfaced to the BAS, and what system was that? And Ron, can you share what system you have at the Ronald Reagan building?
Actually, off the top of my head, I can't. I'm pretty sure it's Siemens as well. It was in New York, but I'm not 100% sure.
Okay, but it was, Dan, I believe, of course, it was interfaced with the BAS, and that's
yes, it was.
That's the advantage of the system, and that's frankly the primary advantage in why you do this.
Yes, exactly.
Another question, and I'm just going down the list. Someone asked when they, Dan, a slide that you had only a half-a-degree reduction at night.
This is Dan Howitt. The actual setback we were working with was a 2-degree setback, but based on outside air temperatures in that particular room, after a half a degree, the room reached equilibrium, or that's only as far as it cooled off at night, and then it started to heat back up the next morning. So that's not a function of the cycle. That's just a function of the thermodynamics of that particular space.
Thanks, Dan. Another question for you, Dan. Why is the testing cycle limited to 4 days, including the weekend instead of 7 or 30 days? And that's, of course, a result of one of the slides.
The 4 days that we presented was representative of about 6 months of data that we collected, both cooling and heating season. So that was just a real clear snapshot.
Next question is, did the wireless network meet FIPS-140-2 GSA standard? And did PBS-ITS approve the wireless network?
This is Ron Allard. The IT guys did review this. I don't remember what standards they applied, frankly, but it was run by the IT security guys.
Thanks, Ron. And then what type of maintenance has to be done in the thermostats?
This is Dan again. Battery life is projected at 4 to 5 years by the vendor. Obviously, the test didn't last long enough to see if that was the case, but I can say that we did not have to change any batteries. Other than that, we found them to be very standalone and reliable. There's no, obviously if you get a bad signal or something coming, you've got to go out and check it. We did not find any failures of that type during our test, and change a battery every 4 to 5 years.
Thanks. And just to get a note from the chat, one of the manufacturers of this system commented that they have installed the wireless pneumatic system in some federal buildings where the tenants did not want wireless, so they installed it in a wireless fashion. So it does provide for that installation method as well. Next question is, can the wireless thermostats be integrated to a Niagara system, as well as can the scheduling and unoccupied occupied set points be managed from the Niagara interface or the BAS?
Generally, an aggregate system sits on top of your BAS, and that's your primary interface. So I would say, once these become points on your BAS, there should be no problems.
Next question was, did you set up a separate wireless network for this? And were there any security requirements that needed to be addressed? And if it was on a production network?
Dan, do you remember the wireless format for this? I don't remember off the top of my head. I mean, we did have to move up from one space, original plan space, as Dan said, because of security concerns. The SCIF is the highest level of security for the government, so they can be very touchy, and sometimes IT security folks are not very flexible. So, but I don't remember the exact format of the wireless or the band they're on or anything like that.
Yeah, this is Dan. I don't recall the details of that. All I know is it did go through a vetting process with GSA's IT security folks, and they approved of it. The details of that are way outside of my area of expertise.
And I see someone from Cyprus just provide some additional information on that, better information on that.
And a question I think was answered, but I'll ask it again. Did GSA or the contractor test the wireless signal prior to installation at the Reagan building?
Yes, there was a audit done. You have to place the repeaters, obviously, appropriately. So there has to be testing of the signal and the measurements.
And Dan, I don't know, are there multiple vendors that provide this technology? Do you know?
That I do not know. I honestly don't know.
Okay. And I will quickly share with everyone. So GSA being a federal agency, we are here to champion the use of wireless pneumatic thermostat technology. But even though at the Ronald Reagan we tested a specific manufacturer's instance of this technology, I'm not going to mention their name and champion that specific manufacturer. That being said, if you call up that report, it's located on the GPG website that Andrea brought your attention to. In the appendix, you can see where that manufacturer is called out. So we tested and are aware of at least one single manufacturer that produces wireless technology. Of course, that was the single instance that we tested at Ronald Reagan. I don't know if Fred, if you want to chime in, did you also use the same vendor in your New York installations? You might still be on mute.
Okay, there we go. There we go. Now can you hear me?
Yes.
Ah, there we go. Yes, yes, we did. I would just like to say, too, that the numbers you presented earlier when we talk about what the savings are, were very conservative because some of those numbers proposed to us were through an ESCO, through the ESPC contractor, and they have to be conservative on what their savings were. Having said that, they had never seen the technology before, but this ESCO, when they were presented with it through us, GSA, they immediately recognized it and said, sure, and we incorporated it into 2 of our buildings. And that one building is GSA's second largest building in our inventory.
Well, and Fred, it's probably fair to say that some of those savings were, I would call it early savings. I got the impression that there were still, the WPT acted as kind of a window to operational problems, and so as those operational problems are addressed, savings would probably increase. And again, at least if not directly, indirectly, the WPT helped with that process.
Yes, yes. Just maybe to repeat what Dad had hinted on earlier in the conversation for everybody's understanding, is that this one building is almost 3 million square feet, and it had a whole perimeter heating and cooling system that was totally manually controlled. Every 12 feet you had to go manually set things. And half the thermostats, I believe, were almost broken. And we didn't have an O&M quite chasing them down or even knew which ones were broken. And we had no control over our perimeter system whatsoever. Now we do. And it's just shocking to us, and it's amazing. And what it's done initially is just to find all the pneumatic leaks that the O&M couldn't find in the past. And now we're going to be able to actually zone control setback. program, and that's going to just save us a fortune. So I think those numbers are really conservative, yes.
And this is Ron Ellard from Washington. I think our numbers are conservative as well. As Dan mentioned, we didn't have great setback at night because we had one place where we were doing the testing, and the other places around it were uncontrolled and not setting back at night. So they did not, the setback, did not set back as much as you would expect. So I think if you did the whole area, the whole building, the surrounding space, the numbers would be more impressive.
I mean, you're finally obtaining a direct digital control system practically for our perimeter. You can enforce set points now. You can actually see each thermostat on the BAS. You can actually send a signal to it. You can actually control your duct static pressure, optimizing that, your supply temperature optimization. You can start optimizing your start-stops, and you've got control of your zones, something we really didn't have in the past.
We had another question as to whether this presentation will be available for the public, and yes, it is. It's available at the GSA Proving Ground website, which I think Andrea shared the location earlier. Frankly, it's a long URL. What I do when I try to go to the website, I just Google gsa.gov/GPG, and that gets me to the GSA Proving Ground website. And then last, you have,
Mike,
I'm sorry, go ahead.
Yeah, this is Dan Howitt. Going back to a previous question about are there multiple vendors, I just did a Google search, and there is at least one other vendor that has the same type of technology. Google is your friend.
Okay, thanks, Dan. One other question, I don't know if we have an answer to it, but someone's asked, on those installations where they were wired, were there any issues of signal drops with long wire runs? And of course, I personally am not familiar with wired installations. Harry Sims, I don't know if you could chat an answer in the chat for the presentation, but that might be helpful to others. But with that, those are all the questions we have. Kevin, do you have any closing thoughts before we close down? And if you do, you're on mute. And Kevin, you're still on mute. Otherwise, I think we'll wrap it up. Andrea, any other thoughts from you?
No, yeah, thanks everyone for joining the webinar. And as Mike said, the presentation will be available on the website as well as the recording of today's webinar. And you can also go and find recordings of past webinars here as well as a schedule of upcoming webinars.
And thanks. I just noticed another question in the chat. So someone asked, how can other products be submitted? As a part of the GSA Proving Ground program, we kind of have a typical annual cycle. And currently we're in the process of selecting technologies to be tested in FY17. And then in the early fall of calendar year 2017, or what would be our fiscal year 18, we will issue an RFI. And if you go to that same GSA website, gsa.gov/GPG, I mean, Google that, it will take you to this long website or URL website. We post an RFI, and that's where we basically solicit the marketplace, if you will, for technology submissions. So watch that, as well as, Andrea, there wouldn't have to be a next slide where there is my contact information, is there?
Mm-hmm. Yes.
I don't see it yet, but so there, if you send Mike Lowell an email, I'll send you a link, or I'll put you on my list. What I do is I collect over the year, that calendar year, I collect emails of interest from people, and when I know the RFI is coming out, I will notify you. Hope that answers that question. Well, thank you everyone for your attendance, and we thank you for your interest in the GSA Proving Ground program.